attention needed to be paid to the microscopic structure. For example, we designed formulate a grid electrostructure, a very dense layer near the separator and the loose layer facing the oxygen side, which give not only a larger portion, larger specific area, but also a low resistance of mass transport. All this novel electrode structure design allow a tremendous increase in both capacity and energy efficiency of the batteries. Another interesting perspective to how to distribute electrode in the electrodes. 3 scenarios here give you a very visible distribution of electrolytes. And more recently, we developed a new type of solid-state lithium-ion batteries. And conventional design has a separate electrode layer and cathode layer. Our unique methodology allowed us to formulate a structure which integrates the electrode layer with the cathode, tremendously increasing reaction area or reducing the internal resistance. As a result, the energy efficiency, second performance, the capacity represent a best among the data reported in the literature. For the flow batteries, we have doing 2 things, improving electrode surface activity and also design of electrode structure. With the design of electrode structure, we have Bohr-doped surfaces. As a result, the electrode has a larger surface area, but also low flow resistance. Because our breakthroughs in design and fabrication of electrode membranes, we have demonstrated that the vanadium redox flow battery can now be high as 80%, and the current density as high as 600 ampere per cm square. In particular, the power density can now be as high as 2.7 watts per cm square at room temperature, which actually is the world record. So in summary, we have made breakthroughs in integrating electrochemistry and thermofluorescence. This unique interdisciplinary approach has brought about significant improvement in the performance fuel cells and flow batteries, as well as lithium-ion batteries. So looking ahead, what is next? We are doing something even more novel, even more bigger. We all know that gasoline is a liquid fuel which can readily transported to anywhere in need, so convenient to be utilized. However, burning gasoline causes air pollution and air climate change problems. As alternative to gasoline, we now propose to create electrically rechargeable liquid fuels. We call this fuel as e-fuel, which is like a gasoline, but renewable and environmental friendly. We believe that using e-fuels as a storage, we will make renewable energy accessible wherever and whenever needed. Even when the sun is not shining or when it's not blowing. Ultimately, issues will change the game of energy storage.
Thank you.
Hello?
Professor Chow.
Yeah.
Yeah. Is it end your talk?
Yes.
Yeah. Thank you.
Yeah.
Yeah.
So I leave now?
No. Prof, we have the Q&A session, Prof.
Okay.
So thank you for the interesting and resourceful talk from Professor Chow Tianso. So I would like to open the Q&A session to the floor. If anyone have the question for Professor Chow, please move and stand on the spotlight and you can start asking question. Professor Chow, can you hear me?
It's difficult to collect the questions using so-called gather.
Yeah. 我回去啊，我应该在这边 share screen。OK。Professor Chow, can you hear me?
Yes.
I try to share back the screen from Gather. Then hopefully, if any participant would like to ask question in Gather, then you can listen to the question from Zoom. It is a bit complicated. Yeah, a bit complicated when you try to integrate two software.
Yeah, it's harder. Actually, got a separate platform, Zoom and Gather. Actually, it's the first time for using Gather.
Yeah.
So I'm not familiar with Gather.
Originally, we like to invite the plenary and keynote speaker all to the same platform Gather, but we worried it creates some troublesome to some for senior people like you, not just to learn Gather for this event, and maybe after that becoming less useful. So we come up with the approach to integrate, but
so next time we get familiar with the Gather.
Yeah. Hopefully, but maybe before we get familiar, when the pandemic ends, we can back to the physical conference, which is more beneficial to everyone. I think, Professor Zhao, I think if there's no question over the floor or they are a bit reluctant or shy to ask here, then I think they can post the question to the secretariat letter and we might forward the question for you. Okay. Thank you, Professor Zhao. Thank you again. Yeah, it's really great to have you in this conference. Thank you for your support. Yeah. Yeah, bye-bye. Bye-bye.
Bye-bye.
Yeah, Anong Nat. Professor Anong Nat from Chulalongkorn University. Please, can I invite you to come up to the stage? And I think you can stand. Yeah. How are you, Prof? Yeah. You can choose one of the spot, not the speaker spot on the podium. Yeah. Yeah.
Like this?
Yeah, yes. Then I move out.
Oh.
And yeah, it is the right timing. I think you can start to moderate the plenary session for the second plenary speaker, Professor Jiri Klemis from Czech Republic. Because of the different in terms of time zone, Professor Klemis won't be able to make it for the live presentation, but he has prepared a recorded presentation that we can play through our system handled by the crew. So, Professor Anong Nat,
Yes.
please, the floor is you.
Okay, thank you.
Yeah.
So, good morning, everyone, and it's my honor to introduce Professor Yeri Jeremy Kemish from Brno. From Brno University of Technology, Czech Republic. Today he will talk about the title of his talk is Smart Agriculture Challenge to Reduce Environmental Footprints Towards Smart and Precision Agriculture. Professor Klemis is the head of a Center of Excellence Sustainable Process Integration Laboratory, Faculty of Mechanical Engineering, Brno University of Technology, Czech Republic. Previously, he was the project director, senior project officer, and honorary leader at Department of Process Integration at University of Manchester and the University of Edinburgh, UK. He also a founder and a long-term head of the Center for Process Integration and Intensification, University of Pannonia, Hungary. He was awarded by the EC with Marie Curie Chair of Excellence, and his track record of managing and coordinating 96 major EC, NATO, bilateral, and UK know-how projects research funding. His research funding attract over 42 million euro. He's a co-editor-in-chief of Journal of Cleaner Production that have the impact factor like 9.297 and Chemical Engineering Transaction. Also the editor-in-chief of Cleaner Technology and Engineering and Cleaner Chemical Engineering. He also a subject editor of engineering that has impact factor of 7.147 and emeritus executive editor of the Applied Thermal Engineering, managing guest editor and of Renewable and Sustainable Energy Review. He's the founder and president for 24 years of the Process Integration for Energy Saving and Pollution Reduction Conference. He's the 7 years of the chairperson of CAPE Working Party of European Federation of Chemical Engineering. He's a member of WP on Process Intensification. He's a member of the ICME UK Sargent Medal International Committee on CAPE. He was awarded by the Web of Science and Publons as a highly cited researcher in 2020. And he is also a top peer reviewer and top handling editor. He authored and co-authored 701 papers in Web of Science, in 101 scientific journal, and his H-index in Google Scholar is 72, and in Scopus is 63, Publons of 56, and his Publons profile has 2,265 reviews for 168 scientific journals and 15,131 editor merits for 23 editorial boards. He also wrote a number of books, and he has been an invited lecturer at 65 University, 12 distinguished visiting professor, and received 5 doctoral honoris causa. He has been supervised 34 PhD students and has been 43 expert evaluators. So please welcome Professor Yeri Jeremy Kemish.
Good early morning, everybody, from Central European time, which is a little bit different to Malaysian time, about 7 hours. So I decided to pre-record the presentation, and you can listen it and play it at the time convenient to you. The title is Agriculture Challenging to Reduce Environmental Footprints towards smart and precision agriculture. I've got 2 co-authors, young lady, Yi Wan Fan. She's the key researcher at my laboratory at SPIL, and her origin is from Malaysia. Another co-author is Dr. Peng Zhang, who is associate professor from Sichuan University in Chengdu, China. Let's start with introducing you my laboratory called SPIL, Sustainable Process Integration Laboratory. And as you can see, is very highly international laboratory. We've got a number of nationalities, number of culture backgrounds, we've got a number of religions, but we all work and live in the harmony. The only problem which we are facing, like probably everybody on this planet, is COVID-19 pandemic, but we are still coping well, and our research results are actually higher than before COVID. I would like also to thank very much to our collaborators. You can see the pictures, names, and affiliations on the right-hand side. There are 2 columns, and those collaborators are not only friends, but personalities well known in the world of science, with whom we published a number of joint presentations. Thank you to all of them. And I would spend 2 more slides to Journal of Cleaner Production and its babies. Journal of Cleaner Production is now young lady in the best age. It reaches 26 years. Impact factor is continuously growing. It seems, based on citation results from previous year, that impact factor will reach 10 for the year 2020. And it's a small miracle because the journal is growing. And last year, we received more than 35,000 papers. 35,000. Can you imagine how many it is per month, how many it is per day? Of course, we are not able to publish all of them, but just cream of the cream. And last year we managed about 6,000. And unfortunately, as I mentioned, we should be highly selective, and we had to disappoint number of authors whose papers still been very good. And for this reason, we introduced, initiated by Elsevier and Elsevier publisher, something which is called Greener Brand family of journals. And there are 10 journals. Some of them are very fresh, babies. Some of them are already walking and ready to go to the nursery. What it means, the journal at the beginning, like the baby, needs a lot of attention. It hasn't got a coverage in Scopus, it hasn't got site score, it hasn't got impact factor. It comes. But all our journals are doing well. I am with my SPIL colleague responsible for those 3, which are marked in green, and those are doing quite well, especially number 2, cleaner engineering and technology. It is already in Scopus, and soon it will get site score. What is very good, even when the journal from the very beginning hasn't got anything, once it gets in Scopus, from that moment, all papers from the very beginning have got Scopus coverage, and the same with site score. So I'm very much inviting you all to publish not only in Journal of Cleaner Production, when we can satisfy just about 10% of submitted papers, but in this Greener Brand family of journals. But let's move to the topic of my presentation. First of all, I would like to introduce agriculture activities in, at the moment, 27 European Union countries. Why? Because this is what is closest to us, and it might be of some interest to you, as many of the delegates of this conference are from Asia. Those are main trading partners for agriculture products from European Union. You can see that it's a little bit unfortunate that the UK left the EU, because the share of export and import is huge, and it is still European Union largest business partner. But for export, the US, China, Switzerland, Japan, and Russian Federation. For imports beside the EU, it's Brazil, US, Norway, China, and Ukraine. So this is about agriculture products. Agriculture by products category, you can see it on this slide. We are always using hopefully credible sources, and the link to the sources is at the bottom of the slide. So this one from Eurostat, and you can see that foodstuff is very important, but for import, vegetables are having big share, and also animal products. Output of agriculture industry is in the European Union is quite wide, from vegetables and horticultural plants through cereals, fruit, forage plant, wine, industrial, up to agriculture services, which they are growing, and secondary activities. And let's move to the very core of the presentation, looking how it looks with global cropland and agriculture revolution. Revolution, I mean development, fast development. And even when it doesn't look like this, farmland expansion poses huge challenges for climate and biodiversity production. I mentioned in the title footprints, and there are many footprints, greenhouse gas footprints, nitrogen footprints, water footprints, poisonous emissions footprints, energy footprints, and all of them are in direct relation of expansion of farmland and, of course, expansion of human population. If we look on this globe, which is actually projected on the 2D, you can see that the Earth has got still a lot of potential for extending farmland. But what are the limits? Limits are climate, and it is both by temperature, but also water. There are places which are very much limited by availability of water for agriculture. Agriculture revolutions, well, agriculture started long time ago. You know, this is from the paper presented by authors from European Christianity background, so they use BC, before Christ, which is actually before our calendar. And everything started from plant domestication. And went agriculture, mechanization, green revolution. Well, in 1960 they called it green, but it wasn't very green because it was introduction of pesticides and chemical fertilizers. But it was a huge leap for intensifying agriculture. In 90s, it was biotechnology, and this century is very much the digital revolution. And this is what I'm going to talk a little bit more. So, what we understand by smart and precision farming? We've got a lot of expectation of benefits of smart farming. Smart farming are very much related to Internet of Things, of IT, information technology, and they produce a lot of potential for intensifying agriculture production. But as English people are saying, it's no free lunch. If somebody offers us free lunch, we have to pay somehow by money, somehow by favor, sometimes by collaboration, and so on. So the potential improvements and gains some of them are listed here. But as I said, it's always something for it. And smart farming requires a lot of new equipment, new data, transmission of data, and it means a lot of electrical power. And electrical power should be delivered to the field, to the farmer. And all this requires some footprints, because we are still not able and probably never be able to make zero emission electricity. Because if somebody is considering solar collector with zero emissions, it is not really the case. It's simplification. Because solar collectors must be produced, which releases a lot of emissions, should be transported, should be installed, should be maintained, clean, and after the moment, about 15 years, should be disposed. And this is the same with wind turbine and so on. If we look what happened over the last 5 years, it's a big progress in precision farming. What it means, precision. There are many different ways how to make some kind of explanation, but precision means to produced from minimum resources. From resources, minimum resources which are needed for farming, livestock, for soil, keeping fertile, but not too fertile. To supply water, but not too much water, just enough. And you can see some ways how it progressed. In many cases, it progressed enormously. I shouldn't forget, even when we are talking about farming, about smart greenhouses, because this is something that is very important part of production, very intensified production. And now examples of efforts towards smart and precision farming, and what are the security challenges? Well, we should start with footprints and circular economy. Again, there are many ways how to specify circular economy. I am using one which we published about 3 years ago. It shows the circularity, but regretfully on this planet we are never able to make 100% circularity, because we always need some supply of energy. And all the energy is coming to this planet from the sun. Otherwise, circular economy before Industrial Revolution was very high. And even mankind, or humankind, better to say, is subject to circular economy, because we are born, we finished in graves, and our remains will become again the source for the new generation. And it happens in all natural resources. But when we introduced the Industrial Revolution, we intensified production, but as I said, always it's based price to pay, and it created waste, residual and emission. And we should try to minimize them. Smart phase management in smart agriculture, this is also what we should deal with, because it's not only to produce, but also afterlife. And it has to be dealt with. And if we like or not, there are horrible numbers about wasted food. There are figures, it depends country by country, but usually the more wealthy country, the more food waste. There are some proven resources from supermarket that about 60+% of food sold in supermarket is wasted. And this is a huge amount, and it's related again to huge emissions, huge environmental footprints. So it's very nice to use drones, cloud, to control everything, but this everything again requires energy and equipment. If we look on waste management in smart agriculture, you can see a lot of different boxes, smart bins, trucks, weighting sensors. We've got sensors for pre-treatment unit, sensors for treatment units, sensors for product formation, and it requires application, and it requires a lot of management. And waste is a very serious issue, not only organic, but also unorganic. We've got in history examples where governments fought by strikes of waste collection and waste treatment. And modern society couldn't live without proper waste management. IoT, Internet of Things, enabled smart agriculture. This is one of very early sites which started to suggest it. But you can see is a lot of smart climate monitoring, which is very important. Livestock tracking, statistics, predictive of production, logistics and warehousing, and so on. And global Internet of Things market in smart farming is becoming bigger and bigger. You can see here from the company which is dealing it within 5 years doubled, and it's escalating. And it requires water supply, hardware products, market in Americas. This is actually only in Americas, not in Europe. So in Asia, it's much bigger. This was one of the more detailed ideas of Nesta company about precision agriculture. And it made a study that almost 20% increase in income is possible but by smart farming. And the farmer is somehow changing from somebody who is in Wellington boots in some kind of agriculture waste and excrement to an operator which is sitting in front of the monitor and monitoring and controlling with help of drones, with help of Wi-Fi from smart tractors, but also from agriculture animals. And these ideas are developing. This is one example of collar, smart cow collar. And each cow can be monitored, and it tells you about health problem, heat problem, heat cycles, can optimize feeding, rumination, stress level activities. And it's not too expensive. It's quite standard, and Wi-Fi is now available more and more even across farmlands. Monitoring weather condition. This is from All Meteo project, which is again very important, because without weather condition we can't make decisions how much watering, how much fertilizing, how much treatment, when we should harvest, and so on. Greenhouse automatization, it's another way, and it has been already well developed, and it controls lighting, irrigation, nutrient receipts, valves and fans, keeping the temperature, telling you about potential dangers of insects, of mold and other things, and also when and how much crop should be harvested. And for this reason, it again developed ways for crop monitoring. And again, you can see what those can do. And it is very useful. Remote sensing of the Earth by satellites. We are collaborating with our colleagues in Kazakhstan, which is a huge country. By territory is larger than Europe, but and they've got quite a lot of arable land, but not so much of water. And this is very important for them to monitor, and to monitor how it's developing and what should be done. And this is application of drones in precision agriculture, which becomes more and more widespread, because drones are becoming cheaper and cheaper, and in agriculture it has got enormous amount of different implementation. innovation. Autonomous tractors. This is a huge leap ahead. It's actually spin-off of autonomous cars, but tractor control is easier than car, because on the farmland there are not too many stupid drivers which are crossing your way. There are not too many careless pedestrians which are jumping in front of the tractor and so on. And for tractors, the problem is mankind, because usually agriculture requires a lot of intensive work in short period of time. And between there are periods where those drivers are not so much needed. So when it's autonomous, the tractor can actually work 24/7 and can deliver fast and even more precise results than the human driver. And it's been developing very fast at the moment. I've got a number of emission reduction solutions for agriculture from this website. It's called Stats Us Insight, and it analyzed nearly 250 startup smart small to medium businesses. You can see some of them here spread it around the world. Simplifies indoor farming, provides access to localized food, reduce methane emission, which is very, very important, because a lot of talk and effort is related to CO2 emissions and carbon footprint. But methane is more than 22-fold stronger greenhouse gas. And CO2 is responsible only for less than 2/3 of greenhouse gases. Also, methane is staying in atmosphere several years, much longer than CO2. And we have to admit, agriculture and nature is big producer of methane. Okay, organic waste, upcycling, precision farming, and if you are interested, you can look on the website which is mentioned at the bottom. So, security challenges. We shouldn't say everything is rosy. Internet of Things, it's a good servant, but it could be very bad lord if it is in bad hands. And like everything, there are studies now saying that if it's in the future war, it will be more Internet of Things war. Because in the future, you don't need to bomb the city. If it's smart city, it's enough to take over Internet of Things of the city. And it can happen also to smart agriculture. Your enemy, if your enemy is able to take about your smart agriculture, they can destroy your crops. They can destroy your food. And probably everybody who studied a little bit previous wars always were won by the side which had more resources available. And one of the very important resources is food. So it's not only plus, there are also some dangers, and we should look in it, and we should be very careful where and how to apply it and how it will be secured. Innovative farming. There are several ways how we can save the land. Vertical farming, aeroponics, hydroponics, aquaponics. it's quite interesting, provides good results, but again, so far it is fine for some vegetables which are relatively highly priced, and we need them close to the supply, because vertical farming and other things can be close to big cities. They don't know so much land, agricultural land, and it has got very important issue. The logistics, supply chains are much shorter, and we can supply fresh vegetables very fast, and even when we need the higher cost for some installments, it can be offset by those advantages. Soilless farming is an alternative of sustainable agriculture. It is similar, as you can see here. And the newest one is something which is called agrivoltaics. It's combination of photovoltaics panels with agriculture. Well, one of arguments against photovoltaics is that they are covering agricultural land. But they can, if they are properly designed, they can live very well in harmony. Why? There are some agriculture products which are not very happy when they've got too much sun, and especially in some periods of vegetation. So those panels can be actually adjusted to provide the right amount of the sun, and it can prevent wasting of water. It can control the growing and maturing and increase the benefits. Plus, of course, those panels are generating electricity, which the smart agriculture needs, and if it's generated at the spot, it very much reduces the losses and wastage, because electricity is not coming from wind farms offshore to 3,000 kilometers inland without losses. The losses are sometimes substantial, and the best way how to reduce footprint and losses is to produce locally and use locally. So this is what is some interesting trend. You can here see it with sheep coexisting with photovoltaic panels, because sheep sometimes need also the shelter, and shelter from sun, shelter from rain, shelter from bad weather, and photovoltaics can serve for this. And the left bottom corner is how photovoltaic panels can coexist very beneficially with bees. So there are options which are not obvious, but they are developing. And this vineyard and photovoltaic panel from France already got the results that water demand was reduced up to 1/3. And in many vineyards, it's a big problem. This is a 3D model of a vertical farm growing leafy greens, different salads and different other things. And as you can see, you can make it totally inside. You can make it totally vertical. You can get some sun from the top, but you can get it supplemented by photovoltaic panels. outside, and it can provide with some energy storage light to extend the vegetation time. And again, it can be very close to the big city, and productivity is several-fold larger than just the field, and the quality of the leaves are very good as well. So what are the challenges? Well, agriculture needs right level of light, right type of crops, type of combination, which is well known for agriculture engineers. You need to get rotation of products. You need diversification for the revenue stream, because sometimes the market requires something more, something less. It should be potential for extending growing season, which some of those ideas which I shown are doing very well, and potential for water use reduction. The advantages, well, we can reduce installation cost when we merge different advanced and smart ways of agriculture with photovoltaics, for example. We can accelerate the energy transitions. We can build closer link with agriculture world to put it closer to consumers, to the big cities, and also reduce upfront risk, because tilled agricultural land was identified as least risk option during series of surveys with solar installers. You know, you can't put photovoltaics everywhere. They can be damaged, they can be subject to crime, but when they are on agricultural land, which is usually protected, not to be losing agriculture product, is double barrel option. It has got reduced legal risk and very good marketing opportunity. So we are coming to the end because my time is getting shorter. We should also measure and watch contaminant mobility in agriculture soil. And here are mentioned nanoplastics and microplastics, but there can be also heavy metals, some agrochemicals, some poisoned chemicals, which are normally in very, very short, very small ppm, but when they are in food chain, coming 10 times, everything is growing. But nano and microplastics are very important. Regarding precision agriculture, is a potential to reduce this 70% of global water use. And irrigation at the moment is wasting a lot of water and causing environmental disaster. You know, I've seen something in Kazakhstan, what is happening with huge lakes called Aral Sea. And they are disappearing. And they are disappearing because agriculture is using too much water. But with smart agriculture, we can reduce it very, very much. We can also have a high precision harvest. We can use agriculture robot based on artificial intelligence. And the robot is nowadays combined, especially with vertical agriculture, is able to pick up the right matured products. This is if it should be full red or partly red, if I need to transport it, I can pre-program it, and it's picking up every day the right rate foods. And okay, this is a little bit too futurist. I don't think at the moment we have got the drones which would provide irrigation, but it might happen in the future. It might happen with the drone, which has got the supply of electricity from land by cable and supply of water by pipe, hose, and it can water exactly the parts of agricultural land which are needed. So options are huge. Also biochar, which can be potentially very good for negative emission caption technology. And of course, it has got potential advantages, but also potential disadvantages. And there are ecotoxicological aspects, there are toxicity and others, but it's another option. And I'm finalizing with some interesting issues which are not fully agriculture, but it's invasion of agriculture to the cities. Green roofs, which can be very useful and beneficial for huge megacities when we've got roofs green. And this is an example from Singapore. Gardens on the move. They've got buses which on the roof have got small gardens which are providing contribution to air conditioning because they are cooling down. And in Singapore, it's raining nearly every day. So you've got the source of water on the roof and it provides, as you can read, green and cool. And okay, 40 minutes of my talk. Acknowledgement to European Union supporting project Sustainable Process Integration Laboratory, SPIL, which is providing funding, and it's managed by Czech Republic Operation Program, Research and Development Education. So thank you very much. I am not with you because of time difference to answer questions, but you are very welcome to type the questions and organizers will transfer to me and I would be happy to answer everybody, all lectures and comments. Thank you very much for your attention.
Thank you very much. Thank you very much, Professor Hamish. So anyone have any questions or comments? And then I will type and then send it to him, and then we can get the comments on the answers. Well, no comments, no question at all. So if not, I think right now is time for a break. So I think so maybe we can have a break for half an hour and then come back at 11:30. So actually it's great, around 23 minutes, and then can start the next session. Okay. So thank you. And so let's have a break and then see you next. Question can type in chat. Yeah. Okay, so you can type the question in chat, and then we'll send it to the speakers. Okay.
Hello.
Professor
Hello, Professor. Hello. Good to see you again.
Can you hear me?
Yeah, I can. Yeah. How about you? Can you hear me? So how's the conference going? Oh yeah, it's good. Yeah. Yeah. Mhm. So how can you link Zoom together? Ah, open to window. Okay. I see. Right. I see. So you from yeah. Oh,